What if our universe is not merely a lifeless expanse, but a system capable of reproducing, changing, and evolving in a way that resembles life? Imagine a bacterium that lives for only 20 minutes. Could it ever realize that it exists inside a much larger living organism? And if our universe is also part of a larger system, are human beings really any different from that bacterium? This has not been proven to be true. But behind this seemingly science fiction idea is a real hypothesis proposed by physicist Lee Smolin: cosmological natural selection. Our universe may behave in ways similar to life. It may change, reproduce, and even evolve. The star-filled sky above you may not simply be governed by cold physical laws. It may be the descendant of something vast that is still growing. Next, we will explore what our universe may truly be from 5 different perspectives. 1. Physical constants so precise that they are almost terrifying. Who tuned them? The physical constants of our universe are astonishingly precise. If gravity were only slightly stronger, all atoms could be crushed together into a dense mass. If the nuclear force were only slightly weaker, no elements other than hydrogen could form. This level of precision is like throwing a dart at the center of a target, while blindfolded and hitting the bullseye every single time. Traditionally, there have been 3 explanations. The first is that it is an incredibly unlikely coincidence. The second is that the universe was designed by a creator. The third is the multiverse. Among countless universes, we simply happen to live in the one that won the cosmic lottery. But today, I want to tell you about a 4th answer, one that has a scientific basis. None of this is the result of coincidence. It may have emerged through evolution. Just like the neck of a giraffe, it did not become long because someone designed it that way. It developed through evolution. 2. If the universe is alive, how does it reproduce? What is the most fundamental characteristic of life? It is not breathing. It is not eating. It is reproduction. So how could a universe reproduce? First, you would have to identify its reproductive organ. In the early 1990s, physicist Lee Smolin proposed a controversial idea known as cosmological natural selection. He suggested that when a massive star collapses into a black hole, the matter inside the black hole may not be compressed into a point of infinite density. Instead, a bounce may occur. On the other side of the black hole, an entirely new Big Bang could begin, giving birth to a completely new universe. This new universe would inherit most of the physical laws of its parent universe, but with a few small random variations, similar to genetic mutations that occur when DNA is copied. Some mutations might make the new universe more capable of producing black holes. Others might prevent stars from forming at all. So which type of universe would leave behind the greatest number of descendants? Naturally, it would be the universe capable of producing the most black holes. 3. Darwin's hammer has now reached the entire universe. If universes can reproduce and mutate, then Darwin's theory of natural selection may also apply. The well-adapted survive, while the poorly adapted are eliminated. A universe with unsuitable physical laws might not even be capable of creating stars. Without stars, there would be nitrogen monoxide black holes. And without black holes, there would be nitrogen monoxide descendants. Such a universe would quickly become extinct in the evolutionary history of the cosmos. By contrast, a universe whose physical laws are just right could produce enormous numbers of massive stars. When those stars die, they become black holes. That universe would then have countless children. Those children would inherit its advantages and continue reproducing. Now, do you understand why the physical constants in our universe appear so precisely tuned? Perhaps they were not shaped so that you and I could exist. Perhaps they were shaped to produce the greatest possible number of black holes. The strangest coincidence is that a universe capable of producing many black holes also happens to be capable of producing life. To form black holes, a universe must first produce massive stars. To produce massive stars, interstellar gas must be able to cool rapidly. And the elements that help gas cool efficiently happen to include carbon and oxygen, which are also fundamental building blocks of life. Human beings may be nothing more than an accidental byproduct of cosmic evolution. A tree does not grow leaves in order to give you shade. The shade is simply a byproduct of photosynthesis. Has this completely changed the way you think about the universe? For can this theory be tested? Many people would say that this is nothing more than a fascinating story. But Smolin's theory has one decisive advantage. It can, in principle, be proven wrong. When he introduced the theory, he proposed a clear test. If the universe truly evolved to maximize the number of black holes, then the maximum mass of a neutron star should remain low enough for many neutron stars to continue collapsing into black holes. Why? After a massive star dies, most of them become neutron stars. Only when a neutron star exceeds a certain critical mass will it collapse further into a black hole. To maximize the number of black holes, that critical threshold should be as low as possible. Smolin suggested that discovering a neutron star with a mass greater than approximately 2.5 times the mass of the Sun would create a serious challenge for his theory. So far, astronomers have discovered neutron stars with masses greater than twice the mass of the Sun, but relatively reliable measurements have not clearly exceeded the threshold of approximately TWO.5 solar masses. This does not prove that cosmological natural selection is correct. It only means that this important test has not yet produced a final answer. Some people argue that extremely massive neutron stars are placing increasing pressure on the theory. Others believe that we still need more data and a better understanding of the ultra-dense matter inside neutron stars. Do you think this is merely a fascinating story, waiting to be disproven? Or could it be a genuine clue to how universes evolve? 5. The final question. Could the universe evolve consciousness? If the universe truly behaves like an evolving, living organism, could it one day develop a consciousness of its own? The human brain is made of approximately 86 billion neurons connected to one another. A single neuron has nitrogen monoxide consciousness, but when complexity reaches a certain threshold, consciousness emerges. If all the stars, galaxies, and black holes in the universe are also connected in a way similar to neurons, could a form of cosmic consciousness emerge? Once the structure becomes sufficiently complex, then what are we cells inside its body? Are we electrons? Or are we part of the consciousness that is now awakening within I? Which idea do you find most convincing? That black holes may give birth to new universes? That the laws of physics may have been shaped by cosmological, natural selection? Or that the universe could one day develop a consciousness of its own? Share your thoughts below and subscribe to Cosmic Theory Lab as we continue exploring the strangest hypotheses about the universe.